Hello, I am John Mushat. This is my Lab 2 assignment video to demonstrate ADC readings, timers, and pin connections to a potentiometer. So I guess we can go over briefly the setup. We have our 3-pin potentiometer, which is going to have like a VIN input, ground, and then a V out. Technically, I think that's how potentiometers work. I'm not really sure. Basically, one of our ADC is going to be hooked up to one of them. ESP32's VCC or 3.3 volt rail is going to be connected to the other end of that, and then obviously the ESP32's ground is going to be connected to the potentiometer's ground. That way, when you change the potentiometer, it changes the resistance and the outgoing voltage changes as well. So yeah, it's going to be, like I said, connected to the 3.3 volt rail and the ground connection, and then our ADC is going to be ADC 1, which is pin 36, which on the Espressif board is A4. So hopefully you can see that. And then we'll be using the onboard LED to demonstrate the duty cycle frequency or the PMW frequency and duty cycle to change the intensity and frequency of the LED based on button inputs, which are also debalanced to be an interrupt. We will download the program and flash it. So hopefully you can see blinking at a standard rate of 10 hertz with 512 duty cycle, so 50% duty cycle. This is the standard one, and then I'm going to, let me see if I can flip this, maybe not. Hopefully you can see that it's printing date and time. I've set it to every 5 seconds just for the demonstration. But yeah, it's printing the correct date and time, and then also the correct day of the week. So hopefully that comes out well. And for the lab submission, it'll change back to 30 seconds, but yeah, just for demonstration purposes. So then we are going to press the button, and when you test out my code, you'll see some debouncing logic just to show that it's debouncing. But now we are in, I believe, frequency mode. Let me double check. Frequency. So as we change our potentiometer, we will see it slow down and speed up. See, it's a little glitchy because I think the ADC values get a little weird, but as you can see, it's like slowing down a little bit. And then if we go up, it increases in frequency to the point where it basically becomes consistently bright. No visible gaps to the human eye. So yeah, we'll go back down. And as you can see, it's starting to become more apparent that it's blinking. So we'll do something like this. It's pretty understandable or readable or lookable, viewable. And we'll press the button again. Boom, we're now in duty cycle mode. So this is going to change how intense our light is. Super bright. And you can barely see it now. So there we go. And then backs that out. As you can see, it also, because it's so bright, it's going to almost kind of look like it's blinking at maximum frequency. I'm not really entirely sure why it does that, but it does. So if we do that again, we can now change our frequency. The potentiometer is, I don't think, the best one, so it's going to have some interesting output, but yeah, that pretty much handles that. So then, yeah, that's pretty much the lab, I think. Whenever the connections functionality, it rotates between frequency and duty cycle when you press the button. Potentiometer is clearly changing the frequency and duty cycle. Button changes it, uses an interrupt to handle the button press, and then also starts a little one-shot timer each button press to debounce it later on. So yeah, that's it.